Okay guys, let's take a look at today's lesson. What we're going to be looking at today is the binomial theorem. You may have some recollection of that from last year, some fond or not fond, I don't know. So there are some benefits to binomial theorems, so let's talk about that. First of all, I want to make sure, let's look at the expansion, the binomial expansion. There are three parts to every term in the binomial expansion. You have to have taken into account all three parts. What are the three parts? The first part is the binomial coefficient. That exists in every term of the binomial expansion. The second part is the expansion of A. And the third is the expansion of B. There are three parts in every term of the binomial expansion. Okay, three parts. Let's talk about the first part, the binomial coefficient. There are two ways that you can get the binomial coefficient. One is by using Pascal's triangle, which is actually my favorite. So let's remind ourselves how to create Pascal's triangle. It starts like this, and down the sides of the triangle are always ones. Ones are down the side. And then what we do to create it is we add the two directly above, and then we start and end with the 1. And then we add these two and we get 3, add those two, we get 3 and 1. And we just go as far as we need. We add those two, get 4, 6, 4, 1. Okay, so that's Pascal's triangle. So how do I know which row to stop on? I mean, how do I know that? So let's say that this was raised to the 4th power. It's just an example. It's raised to the 4th power. Then I would use this line, the line with the 4 right next to the 1 in it. That's the line that I would use for binomial expansion, because if this is a 4, that means I'm going to have 5 terms. Which one of these would give me 5 terms? This one. So there's two ways that you know which one to use. Now you can number them if you want, that's like the 0th, column, the 1, 2, 3, 4, if you want to, that's fine, but that's how you'll know, okay, which row to use. The second way that you can do this is with this formula. And in your calculator, this is the combination formula in your calculator. That NCR formula, that's what this formula is. And you would have use of a calculator, so you could certainly use the formula. I'm fine with that. So that's under math, probability. That's where that formula is. And that's where you could find that this formula for binomial coefficient. Okay, it's just the combinations formula. All right, so we have two ways to get the binomial coefficient. So you just pick your favorite. That's what you can do. Then we have, let's talk about how it's expanded. Basically, each term gets one of these coefficients, so I think we're good with the binomial coefficient. Then what we do is we take the first thing, which we call A, and we expand it from big to little, like let's say this was the 4th, the 4th, 3rd to 1st, 0. We have a 0th term. I know that's troubling, but we do. And the last one, the last piece, B, you're going to do opposites. You're going to take it from the 0th to the 1st, 2nd, 3rd, 4th. So you're going to just do them oppositely. And I have an example on the other page where we're going to go through that. So hopefully that will, if that's confusing, to you, then hopefully that'll fix that up. So do you have to memorize this massive thing? No, you just need to understand what it means. That's all. That's what it means. Now this is something you do need to memorize, because these things are pretty straightforward. That's just basically how you do a binomial expansion. But of course, we're going to have more that are more abstract than that. That would be just so boring, right? And this is the formula that we use on highly abstract problems. So it probably would be a good idea for you to memorize it. So let's talk about it. So n refers to this n, like what you're raising it to. That's what n is. R, in the most simplistic of cases, refers to the term number. Okay, that's the most simplistic of cases. Of course, we have one that's not going to do that, but I'm going to go over this particular formula in detail, and we have two problems that use this formula. So we start with n over n minus r. Then it's a to the r, b to the n minus r. How could you memorize it? I don't know. So one student said, well, this one comes second and this one is last, so that's how they're going to memorize how b has the exponent of n minus r. Those match. So that's a pattern that you might look for to see how you can memorize that formula. Okay. Questions on the formulas? All right, let's move to the examples. So the first one says that we want to expand that, and I am going to use Pascal's triangle. That's what I'm going to do. And if it's okay with you, I'm just going to write out that line that I'm going to use. I'm not going to create Pascal's triangle again. But this goes to the fifth, so I need the line that starts out like 1, 5, with a 5 right next to the 1, which is 1, 5, 10, 10, 5, 1. Okay, those are my binomial coefficients. So, yay, I have that part done. The next part is I need to expand A. This is A. And I need, the first term goes from big to little, so I need to go like 2 to the 5th. And then I'm going to leave some space. And then I go 2 to the 4th, leave some space. 2 cubed, 2 squared, 2 to the 1st, 2 to the 0. That's the expansion of my first term of A. Now to expand B, we need to keep a couple things in mind. B actually encompasses whatever sign is in front of it. Okay, so if there's a negative sign in front of B, that's part of B. If there's a positive sign in front of B, that's part of B. Okay, negative is just part of it. So we're going to expand negative 3x to the different powers, and we're going to start little. The second one we start little. So this is going to be negative 3x to the 0. This is going to be negative 3x to the 1st. Negative 3x squared. Negative 3x cubed. Negative 3x to the 4th. And negative 3x to the 5th. Okay, see how they expand in opposite directions? So now what I'm going to do is I'm going to place those binomial coefficients in front of each term. Just kind of slide them in there where they belong. So this first term gets this 1. The second term gets the 5. The third term gets the 10. The fourth term gets the 10. The fifth term gets the 5. And the sixth term gets the 1. And of course, I kind of wish I'd spread them out a little bit more. They're kind of hard to read, right? We need a lot of room for these guys. So my job now is to clean up each term. And of course, you would have a calculator, so you don't have to do all these number crunching things in your head. We would need to know, we know anything to the 0 is 1, so that negative 3x to the 0 is 1. So we would need to know what 2 to the 5th is. And 2 to the 5th is what, 32? So that's my first term. My first term is 32. Then we move over here. So I have 2 to the 4th, whatever that is. What is that, 16? Times 5 times negative 3. I would personally need a calculator. I don't want to spend the time multiplying all that out. And when you do multiply all that out with your calculator, you get negative 240, and then I have x to the first power. Okay, let's work on the third term. So I have 2 cubed, which is 8. 8 times 10 is 80. And 80 times what? Negative 3 cubed? 80 times 9. That's my next term, which is 720 x squared. Okay, as we see how we're cleaning that up, we just clean up each term. So here I have 2 squared times 10, so that's what, 40 times negative 3 to the 27th, so 40 times negative 27. You know, whatever that is negative 1080 x cubed. Then I have negative 3 to the 4th. What is that, 81 maybe? Times 2 times 5 times 10, so yeah, it's 810 x to the 4th. And then the last one, I have 1 times 2 times negative 3 to the 5th. Whew, negative 3 to the 5th. And actually, this is 2 to the 0, so that's 1. So it's basically 1 times 1 times negative 3 to the 5th, which is negative 243 x to the 5th. And there is our binomial expansion. All right, so now let's talk about this. And some of us are like, oh my gosh, that's taking so long. Well, I want you to think about the alternative. I really do. I want you to think about the alternative. What is the alternative? The alternative is The alternative is foiling all that out. Now think about how many calculations that would involve and how many chances for error. You know, maybe we add something wrong, maybe we multiply something wrong, and that would just be massive. Now, I don't know, maybe like a good Friday night project might do it to like to the 20th power. Oh my gosh, that would be like crazy. I mean, how many pieces of paper would you need for that? Wow. But so to get this whole thing, this is way easier, right? The binomial expansion is way easier. And what if we just wanted the term with x cubed in it? What if that's all we wanted? Would we really want to go through and multiply all of this out just to get the term with the x cubed in it? I know that would be kind of crazy, right? So that's what that little special formula is for, which we're going to work on these two problems right here. If we just want one particular term, we don't even have to go through this much. We can, you know, narrow it down even farther. All right, are we okay on expansion? So finding the binomial coefficient, I just kind of encourage you to just use the combinations on your calculator. So 100C3. If you want to use the formula, you certainly can. The formula is 100 factorial over 3 factorial times 100 minus 3 factorial. So 100 factorial over 3 factorial times 97 factorial. You see, no matter which way I do it, I'm going to need a calculator, right? I'm really not, I mean, I could cancel a bunch of stuff out and kind of wing it, you know, but it would still take a while. And when you do that, you are going to get 161,700. That's my binomial coefficient. Okay? All right, so now let's get down to the more abstract problems, because you know me, right? We're going to have some abstract problems. So these are the ones, number 3 and 4, where we're going to use that little formula. And so I'm going to write the little formula down. So that little formula was n over n minus r. And then we had a to the r, b to the n minus r. Okay, that's what we got. So what do we need it for? Well, okay, again, that might be fun, you know, like a fun little project, but probably not doable on a test. I would not have enough time to expand all that out. So we really need to know how to get, you know, cut to the chase, which is we just want the term that has x to the 5th in it. That's the one we want. That's all we want. Okay, so to do that, we can use this little formula. We don't have to go through all of this. So I'm going to write down what we have. We know what a is. A is 2x, right? That's the first term. And we know b is y. We know that. We know what n is, right? N is 20. That's what we're raising the power to. And we actually know what r is. R is 5. Okay? That's the power of the term that we want. Okay? So really all we're going to do is just plug these numbers into our formula, and like magic, you know, we're going to have our term. So let's do that. So let's plug into this formula. So we have 20 over 20 minus 5. And then we have a, which is, what was it, 2x to the r power, so 5th. And then we have b, which is y to the n minus r. Okay, so one common mistake, I'm just going to point it out. I hope no one in here makes it. Something like this. We think about raising the x to the 5th power, but we forget about raising the 2 to the 5th power. Okay, so please don't leave out the constant. It also gets raised to whatever power. So this is in our calculator, right? This is 20 over 15. So in our calculator, this would be 20C15. Right, that's what we would do to get the binomial coefficient. I mean, you could do Pascal's triangle out to 20, but that would take a little while, and it'd probably be faster just to do the binomial coefficient on your calculator. So when we do that, it's 15,504. And then we do 2 to the 5th, which is 32, x to the 5th, y to the 15th. So cleaning that up, multiplying 15,504 times 32, we get 496, 128, x to the 5th, y to the 15th. All right, that's not too bad, right? We okay with that? So if we were to do that expansion of 21 terms, actually, because the expansion is always one more than, you know what that is, that would be the term that had the x to the fifth in it. Okay? Now, for the super abstract, you're like, what? That was abstract. Well, here we go. One more. So number 4. We want to find the coefficient of the x to the 8th term in the expansion. Well, that seems reasonable. Let's see what it's like. So we're still going to use this formula, which is n minus r, a to the r, b to the n minus r. Okay. All right, so what do we know? We know that a is x squared. We know b is 1 over x. We know n is 10. But unfortunately, we don't know what r is. Okay, r is not 8. We think it's 8, but it's not 8. Why? Why isn't it 8? Well, because both a and b have an x in them. That just kind of muddies everything up. If a and b have x's in them, then r is not 8. So we have the task of figuring out what r is. Once we figure out what r is, our work is, fairly easy. It's like this one. Okay, we don't know. So let's start with the formula. Let's just plug stuff in, see what we got going on. So we have 10 over 10 minus r. Okay, that's our binomial coefficient. A, which is x squared, so we have x squared to the r. Then b is 1 over x, so we have 1 over x to the n to the 10 minus r. Okay. All right, is everybody with me so far? Okay. So let's talk through what we need to do. What we really need is one base of x, not 2 bases with different kinds of x's. That's what we really need. We need one base of x. Is it possible to get these two? Let's think about all your exponent rules, right? Your exponent rules. Is it possible to make these 2 bases into x to something? Is that possible? It is, right? What is this? What can I change this to? X to the negative 1, right? If I have this as x, this one, x to the negative 1, can't I bring the bases together? And what's my exponent rule when I bring bases together? What do I do to the exponents? I add them. Okay, so that's the road that we need to go down. We need an x to a power is what we need. So let's just copy this down. Let's clean this up. So this is x to the 2r, and this is x to the negative 1 times 10 minus r. Okay, that's the first thing we were talking about. How can we make the bases the same? Well, we bring this one up to the negative r. Okay, and then what do? When we multiply common bases, we add the exponents. So I'm going to add these two together, 2r plus a negative 1 times 10 minus r. So let's see what we get here. So I get 2r minus 10 plus r, or 3r minus 10. Well, what do I want? What do I want the exponent to be? So this is the exponent of x. What do I want x's exponent to be? 8. I want it to be 8, right? I want the exponent to be 8. So don't we want this equal to 8? Right? Isn't this the exponent of x? I want this equal to 8 so I can figure out what r is. That's how I find out what r is. We okay? So let's do that. So I get 3r is 18, or r is 6. Okay, we know that r is 6 now. So our, basically, this is downhill from here. So we're just going to take this 6 and we're going to plug it in this, right? So I have 10 minus 6. Then I have x to the, actually it's going to be to the 8th, but we could double check our work if we wanted to. So x to the 2 times 6, x negative 1 times 10 minus 6. Okay, so that's x to the 12th, x to the, what is that? Minus 4. So we know that's x to the 8. And then we put this in our calculator. This would be 10C4, right? That'd be 10C4 in our calculator. And 10C4 is 210. And they actually just wanted the coefficient, the 210. They didn't, I mean, this is just a double check for us because we add those together, we get 8, right? We're just double checking our work. So we get x to the 8th. All right, how are we? We okay? Okay.